Hello and welcome to Identity Office Hours. I'm your host, Mike Schwartz, founder of Glue, and today is episode 98. The topic is Eclipse Decentralized Claims Protocol. A quick reminder to, if you want to support the live stream, please follow us on LinkedIn. And today our guests are Peter Cohn, Principal Cloud Standards Architect at Microsoft, and Jim, oh man, I didn't update the, oh man, sorry. Jim, what's your last name?
Marino, like the old football player.
Okay. And Jim is the founder of Metaform Systems. So I was saying that we always carry on no matter what disasters happen. So my first disaster is messing up the intro. Sorry, guys. But before we dive into it, why don't we start with some quick intros? Jim, why don't you start?
Yeah, hi everyone. I'm Jim Marino. I've been working in distributed systems space for well over the last 25 years, and in open source. And my current projects right now are the Eclipse Dataspace connector and the Eclipse Decentralized Claims protocol that we'll talk about today.
And Peter, how did you find yourself in this space?
Hi, everyone. Yeah, so I'm working now over 20 years at Microsoft, started as a technical evangelist. Yes, I was one of those poor souls selling Vista, but also .NET. That's why I'm working on a Java project today. No, all languages are great. And then I worked a couple of years in the Azure engineering team, working with customers on post-mortem on large issues in very large scaling applications, then moved over to helping design new Azure regions. And as it is, over time you want to do new things. So the last 4 years, I'm now working on international foundational technology standards, ISO, NIST, and CENELEC, and I'm specializing on data sharing in those topics.
Cool. So the topic today is on something called the Eclipse Decentralized Claims Protocol, which I don't think a lot of Identity know a whole lot about. And so I want to start really with just sort of an overview of this area. Jim, could you give us a quick idea? What is a data space?
Sure. A data space at the highest level is basically a context for exchanging data between two organizations. So you can see there's a couple aspects to it. The first would be if I'm an organization, I have to somehow become a member of this data space, and typically there's a data space authority that would handle onboarding into this context, this data sharing context. So and we'll talk about that in terms of credentials and things when we go over the decentralized claims protocol in more detail. But once I've been onboarded, some of the things I would typically do is I want to be able to search the data space for data that other organizations may share. So a concrete example of this would be, say, in a manufacturing type data space where you have a supply chain, right? I might need certain data about the parts that I'm using from my various suppliers. So I may want to go search the data space to get carbon footprint data or other types of manufacturing data. And that would be the first thing, is I would be presented with a catalog of data assets that I'm entitled to see. Once I've basically browse that, I could select a data asset, say it's carbon footprint. I negotiate a contract, which is essentially there may be some usage requirements. There may be some other requirements of me as an organization. And we'll talk about that in terms of claims and attributes. And then once I've negotiated a contract, I essentially get an agreement, which is kind of equivalent of an access token. And then I can go in and access it and basically share the data, but be able to download it or stream it or whatever various types of data that might be presented. So at a 100,000 foot level, that's essentially what a data space is.
Yeah, I would add to that, data space as a name is maybe a little bit misleading, because we are not putting data into a closed space. It's rather a trust context, but historically the name came from Germany, where a group of researchers worked on something what they called Datenraum, which literally translates into data room, and data room sounds a little bit awkward, so it became data space. But essentially, the idea is that data only has value when it moves and leads to insights when combined or analyzed with other data. And what we've seen, especially in Europe, is that people that have data were too scared to have their data shared with others, because politicians, journalists, everybody was telling them data is the new oil, data is the new gold, but they had no clue what to do with the data. And then they read stories about huge online platforms making billions out of data from their user. And so there's this certain angst in Europe that I don't share my data, I keep it in my basement, even though I don't know what to do with it. And so if we want to have a modern data economy where value can be generated from data, data needs to be shared. And to do that, we need to overcome this level of angst of, oh my God, what is the other party going to do with my data? How can I trust the other party to not misuse my data? What about sharing the value of those data? And that's what led to the development of Dataspaces, which then was also put by the European Commission into the European Data Act, and is currently being standardized through ISO and CEN-CENELEC. And the idea essentially here is that you exchange attributes about yourself with other participants in the data space that lead to a point where you can trust the other entity with sharing certain amount of data or certain type of data. So for example, one entity would say, I'm willing to share this data only if you're a German industrial company and you store the data in Germany. If you can prove that to me, then I'm willing to share this data, because then I know it's not going to some American platform that will then make all the money and not share with me. Or maybe this data is regulatory sensitive. You're two healthcare researchers and you say, I need to understand that you're certified to handle patient data the correct way. So first, prove to me that you have those certifications, and then I will share the patient data, but with additional usage restrictions, like I require you legally to delete this data after 30 days or when your research finishes. And Dataspaces are a mechanism to build this trust, to negotiate this data sharing contract, and the data transport then happens in classical data technologies. So that can be streaming technologies, blob storage, data streams, whatever. But the important piece here is that a data space is a technology to negotiate trust that eventually then leads to a signed data sharing contract that regulates how you access the data and what you're allowed to do with the data.
This sounds a little bit like an identity federation. In an identity federation, we have participant agreements that sort of govern the technical tools and the legal rules around how companies can trust each other to log into each other's systems and call APIs and such. So it sounds a lot like a federation specifically for data, where the data is federated, where the data is, in fact, there's an idea of digital sovereignty, where the data should be sitting. It's not a centralized where we're going to store all the data in one place, but we're going to actually, the data resides in a federated manner, with the companies, and they maintain control of it. Jim, can you just say maybe a couple of words about digital sovereignty or data sovereignty and why that's so important?
Yeah, sure. So, a lot of the companies, coming into Dataspaces, right? Like the example Peter just gave of, I'm a company in Europe and maybe, I want to make sure it stays, my data stays within the EU. So, how do you essentially, enable that, right, at a trust level? And what we're essentially doing is saying, through various mechanisms like verifiable credentials, right, that provides an anchor for being able to assert that type of trust, right, in the system. The important thing, the way we're doing this, though, it's in a completely decentralized way. So if you say federation, it's more in a decentralized. There's no central, kind of central point or central identity provider that's that's regulating this. For for a number of reasons. One of which is each organization, obviously wants to maintain control of their own identity and their own attributes. So it's federated, but it's a very loose, decentralized type of architecture.
It's funny because federation has come to mean almost the opposite. To me, federated means you have a number of autonomous domains agreeing to cede some, let's say, legal authority to a central authority for the purpose of establishing trust, but they're federated because they are all autonomous.
So maybe a way to look at this is it's federated at the business level. The organizations participating in a data space need to agree on a joint legal framework on joint business processes. But at the technical level, it is 100% decentralized because we are looking at data ecosystems that can have easily several thousand participants. And federating several thousand identity providers, or maybe even worse, centralizing them in one overarching identity provider, that is not going to work at that scale. So we need to find a system where every organization is responsible for their own identity, but they can participate in a federated business ecosystem by exchanging attributes about their identity that eventually then lead to trust being created for the data sharing contract.
So there's a number of different organizations. Actually, I haven't seen Eclipse in a while. The topic is Eclipse Decentralized Claims Protocol. I want to get to Eclipse in a second, but there was another organization that was referenced in the homework, the International Dataspaces Association, IDSA. Jim, can you say a couple of words? What is the IDSA?
Sure. So it's basically a standards international standards organization that was originally out of Europe and Germany, and they really led a lot of the early data space work. And we'll talk a little bit more about in terms of Eclipse, but they were in the kind of the early forefront of this kind of development of early data space work, which is part of the origins of IDSA was out of the Fraunhofer Institute in Germany, which did a lot of the early research there. And Peter, I don't know.
And how did it pivot to Eclipse then?
Okay. Well, maybe one second. I don't know, Peter, if you want to add any more, because you've been dealing with them pretty extensively. Yeah.
So it ties very closely to the comment I made before about the distinction between technology being fully decentralized, but business models and legal models being rather federated in data spaces. So the way we look at it is IDSA is the organization that works with the consortia that are building data spaces to help them understood and extract from them the requirements for data spaces, and therefore building, let's say, the rules and solution architectures of how can you build such a data space. But they're not a code level organization. So when we started working on protocols and implementations to make data spaces technically possible, we needed to put that into an open source foundation that has good governance model around the source code. And that's where Jim came up with the idea to do that in the Eclipse Foundation. So I'm sure Jim has a lot of good reasons why we are doing that in the Eclipse Foundation. And that's basically led to an environment today where IDSA works very closely with Eclipse Foundation, and members of both are members of the other organization as well. Just very clear separation of what kind of conversation or work happens in what organization. And all of us together are then participating in standardizations in ISO and Senelec and NIST.
Right. Yeah, and so I remember I'm an old-time Java programmer, so I use Eclipse, and we still have developers who still do. But I think sometimes people forget about the importance of the Eclipse Foundation. But Jim, maybe you could say a couple of words, like why Eclipse Foundation?
Sure. So yeah, I'm an old-time Java developer since basically version 1. So for quite a while. Yeah, before all of that, even before Eclipse, the IDE, JBuilder, Visual Cafe, all of those. But essentially, Eclipse is really evolved since, kind of the early or, mid Java period, right? In the early 2000s, when it was primarily an IDE, right? They've really evolved out and have created a really strong open source foundation, similar to other foundations like CNCF or various other places that
Right. Actually,
provide
CNCF is
governance.
in your Linux Foundation, and Janssen Project's also Linux Foundation. Yeah.
Yeah, exactly. So they provide a great governance model. An example of this is to kind of stay on the Java track, right? The old Java EE, all the old standards and specifications have been actually moved over into Eclipse now under the Jakarta project. And that provides, obviously a great governance and umbrella framework for handling those specifications. And when we initially started developing the Eclipse Dataspace connector with a code base that obviously it wasn't called that because it was before Eclipse, but we wanted to go to a foundation that would provide a strong governance model, and based on it's Java, it's based in Java, based on our experience, have a long history in Java EE. For example, we thought Eclipse would be really a great organization to handle that governance, especially the way their open source model works.
Right.
Subsequently, like in terms of the Dataspace, the decentralized claims protocol, Eclipse handles obviously open source projects, but they also handle specification projects as well. So there was a real natural fit, and we brought the code base there, in terms of EDC, the Dataspace components, but we also were able then to evolve a series of specifications as well.
I see. But are they governing changes to Java? Because there's always new proposals for Java features or functionalities. Is that an example of the standards, or does that happen somewhere else?
Yeah, so that's still in the JCP, right? But the core Java piece has been some time since I've been involved in that. But all the Jakarta, so the Java EE APIs, all the Jakarta, like the old like servlet specifications, any of those new kind of EE standards are governed through Eclipse as well. Through similar mechanism. They have the Jakarta working group. We have the Eclipse Dataspace working group. So it's a similar setup.
Okay. Well, it's an interesting choice. I've never heard anything but the best people say the best things about Eclipse Foundation. So I think it's a good solid choice. Let's pivot back into Dataspaces. So Peter, we have these Dataspaces. Individual ecosystems will form their own Dataspaces to address their needs. But to drive down the costs of these of creating these, I'm just going to call them data federations, you need to provide some of the rules, like the legal agreements. What are the types of agreements that are typical to create one of these Dataspaces? Technical and organizational. Like, how do you form one of these things legally?
Yeah. So basically, we are not so much concerned with how do you form them on the legal end. Typically, that's some form of association or consortium that says, hey, we have rules to be a member of this consortium. So similar like in the real business world, you say, hey, I want to start a new association. The rule is you have to be a banking company, you have to be headquartered in Europe, you have to have at least 1,000 employees, and so on. And you can explain those rules as well as technical policies. So you can create membership policies on a Dataspace that say, oh, you can only join if you're an electricity company in Europe, if you are of at least a certain size, if you have specific equipment, if you store your data for this use case in a specific location, and so on. And when you verify all those attributes, then you issue like a membership credential and welcome to the Dataspace. And then you can offer your data to the Dataspace or browse the catalogs from others, where then again at a specific data asset, you will say, hey, this data asset is only available for the supply chain of the Austrian electricity companies. If you can prove that you are one of those companies, you will be able to see this data. And this other set of data here is only available to auditors in European government organizations. So the data space mainly functions as a way to give attribute-based access to data. Think of it as a 100% decentralized attribute-based access control on steroids. Everything in the data space, from membership in the data space to whether you can see that a data asset is even available to share or not, all the way to negotiating access to that data asset, is based on attributes and on claims representing those attributes. And also, another important thing here is, in a data space, we are looking at hundreds of thousands and millions of data assets being shared with lots of negotiations, lots of attributes per data asset. So we cannot have a process where a human interacts with another human from another organization and says, hey, can you make this data available? Can you please upload it to your OneDrive or Google Drive or whatever, and then give me the link? No, we need a mechanism that is 100% executable by machine agents. A piece of software needs to contact a piece of software of the other organization and negotiate whether it will get access to the data or not. And so in the data space, the core protocol that ensures interoperability between participants is the data space protocol. But because we see different designs of data spaces, some might be fully decentralized, some might be federated. We even saw people that are trying to create data spaces with a central control element. In the data space protocol, we just said, insert your identity token here. And the decentralized claims protocol that we wanted to talk about today is one of the technologies that enables us to make this step from expressing the policies that you have to access a piece of data to matching that with claims that match those policies, and hopefully reconcile all the way to the point where you're ready to issue an access token for the other party to access your data. That kind of a high-level description. I hope it is understandable. If not, hopefully it will be understandable when we get into the weeds here.
So let me just play this back a little bit. So an ecosystem forms, and they define some tools and rules. So they define, let's just focus on the rules. They say, here's the requirements to join. They vet the participants. This data system forms, and then they are able to start sharing data with each other. And they do this by agreeing to use this data sharing protocol that you've defined at the Eclipse Foundation. And so I guess let's pick up from there. So if I'm what's interesting is that you say that when you become part of this this federation, this data sharing federation, you're able to obtain a token, and that token has evidence. Each of the attributes might be different evidence, and you present that evidence maybe to one of the participants who's holding data and request that data. Jim, do I have like the flow? Is that about right? Once I'm in, what are the steps after I join the token after I join the federation to be able to start to get some data?
So maybe we can take a concrete, make it a little bit more concrete, so it might be easier for some of the audience to follow. The way I say I'm an organization, I want to come on and access data, manufacturing data. I would typically go in, there's an authority, right? There's some kind of data space authority that's handling all the legal agreements. So I may, go in, there's some kind of application process. I legally agree to these, to these contracts, to abide by, data sharing contracts as defined by the association or authority. Then at some point, I'm going to have my software, and I'm going to say, okay, I want to be issued a token. And that process, I could have some type of secret or proof, right, that I provide that it's me. I've signed the documents, give me the, essentially the token. And what that token is a verifiable credential. So there'll be an issuer, it'll basically deliver to me a verifiable credential and put it into my wallet, which is my software.
And you're saying me, but you actually, when you say me, you're really saying you're an organization who's been vetted by the Federation. And
Yeah.
so this verifiable credential, it's weird because I don't think of companies having wallets.
Right. So this is a new, this is a new thing. This is what distinguishes, basically DCP, the Decentralized Claims Protocol, from other more human-oriented ones. Because typically, a person, you're going to have your personal wallet. You may have your digital ID on there. Like in Europe, they're putting digital IDs and stuff. And this is really an organizational wallet. So it's an organizational credential. There's no humans involved. So
Right.
when I request it, it's actually a piece of software, an agent acting on behalf of the organization that's going to contact the issuer and request the credential.
Mm-hmm. Peter, any thoughts on this is a very new idea that I think would be useful, but how would an organization even manage its own wallet? Or organizations' track record at managing their private keys hasn't been so great. What are are there examples of organizational wallets, and how's this going to work?
So that's one of the reasons why something like the Eclipse Dataspace components exist as an open source project. Because if you look at the projects that are associated, for example, with the Open Wallet Foundation, all of them focus on this human interaction. At some point, you want to show your identity card through a phone app to a website, etc. When we think about Dataspaces and we're looking at where is our world going, it is not going to be the human that goes to another organization and says, hey, we need to negotiate about your stream of sensor data. It's most likely going to be an AI agent. The AI agent is not going to show a cell phone and exchange something through NFC or whatever. The AI agent needs to have an organizational wallet that on the side of the organization is well managed in terms of what credentials can be used in what context, to which identity of the organization are they being tied, because large corporations will probably have hundreds of identities. Just think of merger and acquisition. What do you do if you have negotiated a data sharing contract as company A and then you're acquired by company B? How would you resolve that in the process? So you will have to be able to manage that. And also as one organization, you will be participating in hundreds of data spaces. Because let's say a car manufacturer will need to be in a data space about energy, a data space about their supply chain, a data space about regulations, and so on. And maybe not all the credentials have validity in all the data spaces. And so what we were focusing on with this decentralized claims protocol is, how do we build a component that is anchored in the decentralized identity of the participant and can then provide verifiable credentials based on the context and based on which data do I want to share or where do I need to prove the evidences to my claims. And then how do we move them from A to B? How do we share them? So look, you are looking at me right now in the context of this call. So I will share with you that I worked for Microsoft and that I have a specific job title and so on. But in a different context, you might want to see very different credentials from me. You might want to see whether I'm a guy that knows how to raise pigeons or not, which has nothing to do with my Microsoft credential in this call. So we needed a whole new protocol, a whole new system to figure out how do we hand this information that matches an evidence to a policy that the other side has. And any protocol that we looked at that deals with verifiable credentials always required a human in the loop, a human that takes out the wallet and approves that a piece of information from that wallet is being used in that transaction. Well, if you have hundreds of AI agents going out on your behalf, collecting data and sharing data, you cannot click fast enough to do all those approvals. So you need a new type of protocol that enables the automation of this process. And that's where Jim and a lot of other committers who joined in the Decentralized Claims protocol specification at the Eclipse Foundation to build this type of protocol.
One of the benefits of verifiable credentials is that they're better at protecting privacy. But in these data sharing agreements, is privacy really as necessary? Don't you actually want a chain of custody in a way, or a digital chain of trust to see who accessed the data and how was the data used? And Jim, do you see privacy as one of the goals here, or one of the benefits, or is privacy not as important in this use case?
No, it's actually very important, but it's a certain type of privacy. So it's not anonymity, right? So the privacy is really between the two parties, conducting a data exchange, because any data transfer rights an agreement between two different organizations. Where the privacy comes in is, if I'm an organization, I make an agreement with another organization, I don't want to have a third organization, say my competitor, or even necessarily the data space authority, right, knowing about that, because those agreements could be confidential, could be highly sensitive, right? So in traditional identity systems, if you have a centralized identity provider, especially in terms of like OAuth 2, you're always at risk. The identity provider always knows at least which two parties are talking to one another. So, for example, if I need to create a token in OAuth 2, right, I'm going to go request from my identity provider, and I'm going to have to set the audience to the party that I'm speaking with. So in that example, right, the identity provider is privy to at least knows that I'm talking to another organization, which may be confidential. Right. With DCP, there isn't a central. I don't have to go to a central identity provider to create those tokens. So
just to push back on that idea a little bit, Paul Bastian and Christian Bormann are working on a new draft for attestation-based authentication, where instead of let's say requesting, basically you can request the you can present the attestation during the client authentication and say, I would like this this token. I guess you're right. You're still getting a token for the audience. But okay, so Peter, let me.
So Mike, maybe one more important point, because you just talked about privacy and confidentiality here. And a super important design point here was resiliency. Because if you're building, let's say, a supply chain network for the European automotive industry, that's 500,000 companies. If they are dependent of a centralized service, then that would be a single point of attack, a single point of failure. 500,000 companies need to stop working if that thing goes down. 500,000 companies are at risk if that thing is being attacked and hacked. So an important design point for us was every participant in the ecosystem needs to be responsible for everything pertaining to their identity. And if they are being hacked or if they go down, it does not impact the rest of the ecosystem. So it has to be very similar to the design principles behind the internet. And also, even if you join a consortium and agree on one contract, you can leave the consortium the next minute or be kicked out for bad behavior. That does not legally stop the contracts that you already agreed upon, because maybe that is critical data in a mission critical service. So you also need to be able to continue function once you leave the consortium. Because there might be legal obligations that persist.
These properties also exist in identity federations. For example, in the open banking federations, an outage in one wouldn't affect any of the others. The agreements, especially the confidentiality agreements would still apply even after you leave. These are all true in federated environments too. I think what's really different here is, the technology we're going to need to move from this two-party system of IDP and SP, or OP and RP, to holder, issuer, verifier. I think, is not only are the sort of the let's say the participants going to have to adjust, but the trust models themselves are going to have to adjust. And I think you're actually creating what I've been saying for years, which is that all of our current federations are based on these two-party systems where we have an issuer and a verifier, but no holder. And you're introducing the holder in and saying, now we need to build new types of federations. So I think you're really on the cutting edge here of this new technology. So it's definitely very, very interesting. I want to pivot into attestations, like the word of the year. And so, Jim, I wanted to pivot to you. So in the drafts I was looking at, which you say are now outdated, there was this idea that when a participant wants to access data, they present attestations in order to obtain a token, and then they present that token in order as evidence that they should be allowed to access data. Can you walk us through that a little bit more? What are those attestations that they present, and what's contained in them, and how does that enable the token issuer to know that they should issue the token?
Right. So essentially the idea is in any type of data space communication in any of the protocols, right? There's a token that's presented. So if I'm making a request, an agent is an agent, I'm making a request in the header. If generally it's a REST request, so in the HTTP header, there's going to be a token, and it'll be specifically it'll be a JOT token. That JOT will be basically a self-issued token. So it's going to be a token that the identity provider that's under my control has basically stamped, okay, and in that and signed. And in that token, the identity is going to be a decentralized identifier. So basically this is all based on W3C technologies. The DID will have, if you resolve the DID, typically it will be a web. What we use is web DIDs. There's other types of DIDs, like especially with blockchains and things where we've selected web DIDs. You'll basically resolve the DID document, and in that DID document will be my public key. Okay, and then so if I send the token out, it's going to be a JOT. The JOT can be verified with basically by resolving my DID document, getting the public key, and verifying the signature of the JOT token. The nice thing about this is it just uses standard off-the-shelf technologies today. So any type of JOT, library for working with JOTs will work with this.
Right. But the thing about JOT's like saying JSON, right? We don't know what's in that payload. We know it's signed in a standard way, right? But a lot of the challenge around JOTs and getting interoperability is getting alignment of what's actually in those tokens. You can build libraries because this claim will always be there. So you're not looking to profile any tokens. I'm sort of surprised.
Right. So let's walk through how that works and why we can't do that. So the idea will be, so say for instance, I'm making a request for data, I being an organization, right? And part of that, the requirements for the data is there's an offer. If I talk to another company, I view the catalog. In order to access that data, one of the policies associated with it might be that I have to be a company registered in Europe. Okay, I have to be a European company. And there's going to be a policy, and there's basically a standardized policy language that we use in Dataspaces that's standardized and specified. That policy, it may say, okay, I have to be a company registered in Europe. That in that particular data space, the attestation you need is a verifiable credential that has, say, an attribute in it, right, in the subject that says that I'm a European company.
There'll always be application-specific claims requirements. That's a given. But are there no shared claims that could be defined? So we can build libraries because we know we can always expect the standard claims, and there'll always be extension claims for ecosystems. Were there no standard claims where you could define some type of standard token that would then the ecosystems would extend?
Right. Well, we've defined the standard token in terms of the format of the JOT, right? What typically goes in there, the semantics about it, but then each data space is going to be different, right? And we're seeing that. So there's going to be certain verifiable. So, for instance, in automotive, that's Contain X is an example of an automotive data space in Europe, involving basically most of the large German automakers and their supply chain, right? So they have specific requirements there. So they need tokens, say, for instance, if you're a dismantler or the type of role of a supplier in the automotive. So it's all basically the industry specific. So we provide the shell, and then each data space is going to define the specific tokens or credentials in this case.
Peter, when actually I got the idea to talk to you guys from, I'd written this LinkedIn post about token-based access control, and Peter, you responded something to the effect of, I think we're already doing this, which has been great for me to see, because I had this idea, and the fact that I see it aligning with what people are doing in the real world, I took as like encouraging, supporting evidence. But can you talk a little bit about why you think something like token-based access control might actually fit your model of how you're looking at how access control needs to evolve?
So when you think about a fully decentralized data space, there's no identity provider that is shared between all the participants. So you cannot guarantee the identity of the other person. But what you need is a set of attributes of this other person that then lead to you making a risk-based decision. Do I trust, organization, not person, but do I trust the other organization? So if I specify 100 policies and you have 100 attributes, maybe 90 are fine to trust you, or maybe I'm in a use case where if there is a single one that you cannot fulfill, I'm sorry, I cannot trust you. But it is very impractical to have to validate thousands of policies at every single step of what you're doing. So basically what we do with the DCP here is that you have hundreds of policies and hundreds of evidences, and at some point they are matched and evaluated, and then you get an actual access token to that specific data stream. So that data stream, that token, identifies one counterparty for one specific operation. The next guy will get a new token, which might have a different meaning because maybe we have negotiated a different usage contract for this data. So where we are getting to is that at some point, I might not even care if the other party is a specific organization. Maybe I only care about them being a European energy provider because it's rooted in an EIDAS ID from a government that guarantees that they're a government-accredited energy provider. But I don't care if it's the energy provider A or B, because that's not relevant for my use case. So I will have a bank of evidence that then results in an access token. And with that access token, I will have access to the data. And that access token can be managed and revoked at any point in time as well. So I might not even need to know the actual identity for specific use cases.
Right. So we need, so the issuer of the access token has to be able to map the tokens presented against policies and be able to create, okay, here's your final authorization. Jim, any thoughts on this topic before we go to last thoughts? I don't know if you had time to read the token-based access control article, but previous access control models like role-based access control or relationship-based access control, I just, what you're describing is a situation where there isn't even a person here. It's not even a piece of software. It's actually organizational relationships that we need to model. Do you have any thoughts on whether token-based access control is maybe a good way to approach this, or any holes in that idea?
Yeah, no, I think it is, and in one respect, I think that's what we're trying to do. It's just, as Peter mentioned before, it's the scale at which we're trying to do it at. Right, these data spaces typically are literally tens of thousands of organizations, especially when you get into manufacturing type industries, and that's the challenge. How do you do that in a decentralized way, where there's no one centralized or group of centralized identity providers, and how you do it in a way that's resilient, right, to failure and disruption.
We're a little over time, but this is a good discussion. And Peter, before we go to last thoughts, I just want to ask you one last question. We talked a little bit about a US company called Altana before we started the live stream. And also, I had Rajiv Rajani from iShare as a guest maybe 2 or 3 weeks ago. Can you talk a little bit about what does iShare accomplish, or something like the approach that you're using versus what Altana is trying to do by creating almost a private clearinghouse for data?
So the important thing about iShare is that they're complementary to the work that we're doing. They're a trust framework. So iShare defines which policies have to be mapped to what kind of evidences, and what type of evidence do you need to bring to be considered trusted in the iShare model. So it's a natural fit for what we're trying to do, because we don't want to define the model with what are the questions that you need to ask to have trust. We only give you the mechanism to exchange the data and eventually arrive at the token. And so we see that similar to how you build HTTPS on HTTP, that you have many different root certificate providers and you decide which root certificates you trust and which don't. The same will happen here with the trust frameworks. There will be competing trust frameworks, some for specific domains, some for specific regions in the world, some for serving very specific governments. And you, as the person sharing data or the organization sharing data, will decide which trust frameworks are permissible to share the data with. Same way how you pick which root certificates you want to have in your browser accepted when you go to HTTPS. And think about it the same way that HTTPS added a secure channel on top of HTTP, Dataspaces add a trusted channel where you know enough about the other party to make the decision whether it's business risk or not to share with them.
Right. Quick thoughts about Altana. This is a company that companies join their network and share data, and they provide some of the legal, but also the technicals. But then they use that data to create an AI model, which they get a lot of business value about. But why should we, maybe consider moving to open standards versus just joining something like an Altana?
Well, Altana built this model independent of Dataspaces. Lots of great idea, lots of overlap in the ideas. But in the end, it's one company that has most of the economic benefit and then resells the insights gained to its customers. Dataspaces are trying to be more democratic, but there is no reason why the business model of Altana couldn't be built with a dataspace. Or on the other side, Altana could be a great participant in a supply chain data space, because data stays at its source unless it's needed for a computation and a contract is in place. So that's where Altana has the same mental model. But what Altana also can do in a supply chain data space is to offer their data under their own decision, which trust framework, under what conditions they want to share, with what usage policies. So I don't see that as an either or. It's just they came to the very same conclusion, but with a solution path that is centered around one vendor and one vendor ecosystem, while we are trying to build something that is rooted in standards and will produce a global decentralized ecosystem, irrespective of the domain that you want to use it in.
Interesting. So in fact, your standards could actually lower the barriers for new entrants like Altana to establish data sharing and make valuable information from that data.
If we are successful, there will be a point in time where any company is using Dataspace protocol and decentralized claim protocol as easily as they're using HTTP today. Okay. Think of it this way. The World Wide Web was built to share information with humans. Dataspaces are being built to enable machine-to-machine information sharing at a much bigger scale than what the World Wide Web has done for humans.
That sounds like a good place to pivot to last thoughts. So let's do it. Jim, why don't we start with you? last thoughts?
Yeah, so I encourage people to take a look at the decentralized claims protocol, also the Eclipse Dataspace components. There's sample applications and a minimal viable data space demonstrator that if people are interested in looking at the technology and going in deep, check those out.
Peter, last thoughts before we break?
I will second that. If you want to participate in building this, please join us at the International Dataspaces Association and at the Eclipse open source projects, and maybe also at the Eclipse Dataspace Working Group. If you're scared that this is too technical, but you still want to support us, please make donations to the IDSA or the Eclipse Dataspace Working Group, because that is a resource that is always needed to build stuff.
When's the next time you actually get together in person?
Good question. We started this mostly online as during the pandemic times, so we are quite used to the virtual images of each other. But there are regular meetings of the working groups. There are plenty of conferences where there's a chance to meet each other.
Well, Internet Identity Workshop happens twice a year, and there's a lot of certainly verifiable credentials and OAuth know-how who show up at that forum. It's a good neutral place to collaborate. Microsoft's been a longtime sponsor of it. Cool. Well, I think we're over time. I don't normally go over time. I think that's how important this topic is. So want to say thank you to the guests, Peter and Jim. Great conversation. Thank you to the audience. We'll see you next time for an episode on a new standard proposed by an ex-Microsoft guy, Dick Hart, and Carl McInnes from Okta. We're going to talk about OpenID provider commands. So with that, we'll see you next time.
Thank you for having us. Bye-bye.